Hello, and welcome to Carolyn's Quarantine Kitchen Chemistry class. This week we'll introduce you to a new concept, solutions. Some say it's silly, but there's all sorts of stimulating science surrounding solutions. There's a lot of chemistry-specific vocabulary, some of which have homonyms, like solution can mean the answer in math, or suspension can be a type of discipline, or concentration can be how much you're focused. But in chemistry, these have their own unique definitions. This week, you'll get to do some reading, fill out a vocabulary chart, watch some videos, do a lab simulation, and practice some problems on your own. But first, I want to give you an overview of the solutions unit in this video. If it helps you learn, you're welcome to fill out notes that go along with this video. They are attached to the email from your teacher or posted on your class website. A solution is when two substances are combined to form a homogeneous mixture without a chemical reaction occurring. In solutions, they have the same composition, color, and density throughout. A solution has two parts. The example I'll be using in this video is the powdered drink Tang. Tang was invented in the 50s, but became famous in the 60s when it was used on space missions. The inventor of Tang also created Pop Rocks and Cool Whip and an instant set Jell-O. Tang is a powdered drink that you mix in with water. So in a solution, the two parts are the solvent, which does the dissolving. In this case, it's going to be water. And the second part is a solute, which is the particle that gets dissolved. In this case, it'll be the powder Tang. If you take a look at this picture, you'll notice the dissolving process. This is called solvation. It's where an individual solute ion breaks away from the solid crystal. The negatively and positively charged ions become surrounded by solvent molecules. You can see the polar nature of water basically surrounding the different Na ions or Cl ions. This is simulating the dissolving process of salt as it dissolves into salt water. You can increase the rate at which something dissolves by one of three ways: stirring the mixture, decreasing the size of the solute by crushing or breaking up the crystals beforehand, or increasing the temperature. There are other categories of mixtures besides solutions. There are also colloids and suspensions. An example of a suspension is Italian dressing. It's a heterogeneous mixture in which there are two substances clearly identified. You can clearly see that there are different types of things brought through. It often requires agitation in order for it to be mixed together, and if left over time, they'll separate on their own. There's also colloids. An example of colloid would be milk. And another example is mayonnaise. Colloids are heterogeneous mixtures of two substances. The particles are larger than the substances that are in solution, but they're smaller than suspensions. They don't settle out over time, so you don't have to agitate them before you pour, but they can be differentiated using a process called the Tyndall effect, which is a scattering of light. They're often confused for homogeneous mixtures because they appear to be uniform throughout, but they are not. I want to show you a chart that shows 9 different types of mixtures. Those mixtures can be solutions, suspensions, or colloids. Feel free to pause the video to be able to analyze the chart in more detail. Solubility is the amount of solute that dissolves in a given quantity of solvent at a specified temperature and pressure to produce a saturated solution. It's often measured or expressed in grams of solute per 100 grams of solvent. There are 3 terms associated with solubility: saturated, unsaturated, and supersaturated. In saturated, it's when a concentrated solution holds the maximum amount of dissolvable solute at a certain temperature and pressure. Any additional solute would not dissolve. Unsaturated is when any solution contains less solute than a saturated solution at the same temperature and pressure. More solute can yet still be dissolved. In a supersaturated solution, It's an unstable solution where it holds more dissolved solute than can theoretically be held at a certain temperature and pressure. This is very uncommon. When you add a seed crystal or disturb the solution, it will result in a crystallization, and then the remaining solution will be saturated. So far, it's been a lot of vocabulary, but chemists are most interested in quantifying things. So, in order to simply and consistently quantify solutions, they have two terms. One is concentration. It's a measurement of a solvent's ability to dissolve a solute. It's quantitative, and it's usually in grams or moles of solute per volume of solvent. Now, molarity is a specific measurement that we're going to be focusing on this week. In molarity, the measurement is of the solution's concentration. It's specifically how many moles of the solute are dissolved per liter of the solvent. The units are moles per liter, which is also called molar. Thank you. So now for the example of Tang. Tang has a molar mass of 192.12 grams per mole. So if I wanted to make a 1 molar solution, I would need to have that amount of grams in 1 liter of solution. So here's a 1 liter water bottle, and here I've measured out 192.12 grams of Tang powder. I've also measured out half of that, which is 96.06 grams. If I put this in 1 liter of water, then I'll get a 0.5 molar solution. Next, I have 1/4 of the molar mass. That's 48.03 grams of Tang. If I put that in 1 liter of solution, you'll have a 0.25 molar solution of Tang. Lastly, this is 19.12 grams of Tang. If I put that in 1 liter of water, the whole solution will have a 0.1 molar solution. How I did these measurement processes is I put the standard container on the scale, pressed tare, and then poured the desired grams amount into the container. So, to get 0.1 molar solution, I need to have 19.2 grams. And there we go. 19 grams of solution, 19 grams of Tang powder will be able to create a 0.1 molar solution when it's placed in 1 liter of the solution. All right, and there you have it. This is 0 molar Tang, where it's just pure water. This has 19.21 grams of Tang, so it's 0.1 molar. This has 48.03 grams of Tang in 1 liter of water, so it's 0.25 molar. This one has 96.06 grams of Tang in 1 liter of water, so it's 0.5 molar. And this last one has the full 192.12 grams of Tang in the 1 liter of solution, so it's 1 molar of Tang. Thank you for watching, and I hope you enjoy this week's videos and lesson instruction activities about molarity.